Okay, so I'm presenting this morning on behalf of Dr. Dave Simmons. Oh, I don't know if this chat is for me. No, okay. So on behalf of Dave Simmons, he's currently teaching a class as we meet. So first of all, you've heard a lot about different types of engineering. I just want to give you an insight into what civil engineering comprises. So it's about designing and constructing key infrastructure that we see around us. And those might include bridges, roads, water systems, large buildings, railway tunnels, and coastal flood defences. My background is actually in coastal engineering. I'm a professor in environmental fluid mechanics, and my interests really are around the interaction of fluids with structures, and the fluid of interest for me is the sea. So I look at pretty much anything to do with extreme wave impacts with structures. Civil engineers, they imagine, design, create, and in fact most engineers do that as well. Civil engineers can work in a design consultancy, which would be largely office-based, or working as civil engineering contractors on site. And our students go into both of these fields. You see some students here on placement years using software that we would also use in the university. So things like Flood Modeler, which we use for modelling river flow, looking at flood risk. Software such as LUSAS, where they look at structural analysis, and Delft 3D, where they might model waves interacting with structures. As Adam said about mechanical engineering, we're very keen on interdisciplinary design, and I run a module for our final students where they feature a very large project which requires disciplines across civil engineering that I'll mention in a moment, but has also in the past involved the mechanical engineers as well. And we set a very large project, a scheme, such as last year we had a redesign of the infrastructure on Drake's Island, which is a historic island just off the city of Plymouth in Plymouth Sound. So it's an opportunity for the students to engage with local companies who might actually be doing the real design with architects. And we can have visits to those sites, and those developers can actually come to the university and tell our students a bit about the real projects as well. So the sub-disciplines within civil engineering would include structures and materials, all the way from the fundamental mathematics behind those to the applications. Geotechnics, geotechnical engineering, so the art of making the earth more, or the science rather, of making the earth more habitable, looking at soil and rocks. Management, as has been mentioned by a couple of people, is a core part of engineering. And then the practical skills of surveying and the calculations behind those. And then my own particular field in hydraulics and coastal engineering, looking really at the fluid mechanics, looking at the water management around flood engineering, and looking at the details of the kinematics. And here's a typical image which shows the development of the site around the Olympics, and a before and after picture, and how all of that was looked after by civil engineers, a lot of geotechnical engineers. I think we might have been involved in some of the groundwork engineering of that. So why study engineering in Plymouth? Well, our staff are passionate about education. Here's a few of my colleagues. Plus we have, as well as on the teaching side, we have world-leading research, and our programmes are civil engineering and civil and coastal engineering. And with my coastal engineering background, I know most about that, so I'll talk mostly to that. But in terms of the interests around coastal engineering, this is a structure that was badly damaged by the Japanese tsunami that affected that shoreline. So they had large revetments down thousands of kilometres on their shoreline, and they were very badly damaged. And we did some site surveys there. We have some images of a wave energy device that is being tested in our ocean basin facility. The structure on the right is a finite element model of a rock lighthouse. So we're interested to see how the wave loads on these rock lighthouses affect the structural stability. In fact, this original part of the project was done in association with one of our students, one of our MSc students. Another area that I think Deborah touched upon was our offshore renewable energy research. So Plymouth University, we're a leader in that field, and we're looking at the moment at offshore wind energy and of the floating turbines. In terms of our students and their routes to professional qualifications, so if they want to become incorporated or chartered engineers, they would come in here on the left-hand side. Various people have mentioned about the foundation degrees, but if the entry qualifications are good enough, they can come straight into the degree programme. From there, they can do the 4-year MEng, or as somebody else mentioned, you can do a 3-year BEng plus an MSc. Some time spent in professional practice, the chartered exam, and then the students will become chartered or incorporated engineers. Not shown here, but also touched upon by some of my colleagues, is a placement year. So we very much encourage our students to do an industrial placement at the end of their first 2 years. And I concur with the experience of seeing quite a dramatic change in our students who are able to do that placement. And one of the highlights of my job is to visit students who are in placement and to see what they are doing. And they all step up to the challenge, and they certainly mature a lot in that period of time. Deborah has already mentioned the fact that we're building a new home for our engineering students. So this landmark building will be situated on the campus, renovating one of our very large buildings and making a wraparound new building. And this will be co-locating our researchers and teaching staff. There'll be landmark new facilities. I won't spend any time actually talking about our existing civil engineering facilities. They're the standard sort of beam testing and geotechnics labs, as well as the coast laboratory. But they will all be co-located in this new building. The coast laboratory won't be moving, that'll still be in our marine building situated here. But we'll have brand new labs here for our teaching and our research. Okay, so this just reiterates again our different programmes. These are the 2 undergraduate programmes, 3 years or 4 years, leading to either incorporated or chartered engineering status. And if you do a BEng, you can go on to do the MSc and become chartered as well. World-class facilities, which have been mentioned. This is the ocean basin. And our graduates are in really strong demand. The companies here are some of the highest esteemed companies in the UK. We've also got a very strong industrial advisory committee in the civil engineering area. And this meets periodically, and we have input from the industry players to inform our teaching programmes. So they can tell us what industry needs, and we can modify our programmes to suit. We also have a very active civil engineering society, which is run by the students for the students. So maybe occasionally a staff member might be invited to something, but essentially it's our very engaging undergraduate students who run this. They organise visits to local engineering sites. They invite speakers to hear about new projects. They have organised really successful careers events, and they have been known to organise some good football matches as well. We have very good employability statistics, and we then go on to have very strong relationships with them in industry over a number of decades now. That's obviously really good for placements, for new students going into their companies, for student projects and the like. And here's just a video of one of our research projects. Students doing their dissertations, so in stage 4 of their programme, they will have the opportunity of doing experiments or numerical modelling in association with some of our researchers. So because of us being world leaders in offshore renewable energy and other areas, they can also get an exposure to those cutting edge experiences. So it's not just the industry applications, it's also the cutting edge research, which is really inspiring for some of our students. This is a particular research project that was funded by the European Union. This was looking at the interaction between wave energy devices in our ocean basin. And then just finishing off with an aspirational, inspirational slide showing the civil engineers of tomorrow. So I'm very happy to answer any questions. I'm certainly not as well versed as my colleague Dave Simmons, but I'm very happy to stay around and answer questions as appropriate. So thank you.